Given that the probability of A is equals to 0.45 and that of B is equals to 0.25, determine the probability of A or B if A and B are mutually exclusive events. So the probability of A or B is equals to, generally, right, P of A plus P of B minus P of A and B. But if they're mutually exclusive, the probability of A and B is 0. They cannot occur at the same time. For instance, the probability that it will rain and the probability that it will not rain, those two things, those two events, they cannot occur at the same time, right? It cannot rain and not rain at the same time. So the probability of A or B, because they're mutually exclusive, will be equals to 0.45 plus 0.25 minus 0, B, which will give us 0.7. So that is the probability of A or B, given that they are mutually exclusive. 10.2, let's take a look at 10.2.1. A survey was conducted in one of the schools in our province with a population of 50 teachers. 30 of the educators indicated that they each own a car. 2 educators were randomly selected, one after the other, without repetition. So let's take a look at this. Oh, well, the first question, represent the given information on a tree diagram. Clearly indicate the possible outcomes of the event. Okay, so let's take a look at this, right? We are told that 30 of the 50 teachers say that they have cars. 30 of the 50 say that they have cars. Well, let me represent it in the following way. So 30 of the 50 say that they have cars. So how many don't have cars? So how many don't have cars? Should be 20 over 50, right? So let's say that one of the teacher, that is the first teacher to be selected randomly, has a car, right? The first teacher to be selected randomly has a car. So what is the probability that on the second selection, the teacher selected will also have a car? So there is no replacement here of any sort, right? So now we are left with 49 teachers because the first teacher with a car has been selected, right? And then how many teachers with cars left? 29, because there are 30 in total. And then let's take a look at the outcome of having a teacher with no car if the first teacher selected has a car. So teacher with cars, or with no cars, not with cars, with no cars, we still have 20 teachers with no cars, because the first teacher that was selected is a teacher with a car. But our total of teachers now is 49 because we have removed one teacher. Okay, and then let's take a look at the other way. The first teacher selected does not have a car. What will be the probability that the next teacher selected has a car? So the teachers with cars is still 30, right? But the total is now 49. And then now the other outcome, teacher with no car. So the first teacher selected has a car. So of that 20, we are left with, the teacher selected does not have a car, right? Which is 20 teachers. And now that we want to select the second teacher, we are left with 19 that don't have cars. So that is 19 over 49, because there is no replacement. We are selecting one after the other without taking the teacher that we've selected first back into the selection pool. So this is our data represented in the form of a tree diagram. Okay, 10.2.2, find the probability that only one of the educators selected owns a car. Okay, so let's take a look at this outcome. This outcome here, let me change my color. This outcome here is car. Both teachers have a car there. And then the outcome here is car. One teacher has a car, the other one does not have. Here, the first teacher does not have a car, the second one has. And here, lastly, they both don't have cars. So 10.2.2, find the probability that only one of the educators selected owns a car. Only one. So let's take a look at this. We're interested in this outcome because in this outcome, only one teacher owns a car. We're also interested in this outcome because only one teacher owns a car in that outcome. So let's say that the probability of C and not C, the probability of having the first teacher own a car and the second not have, will be the probability of owning a car for the first teacher, which is 30 over 50, multiplied by the probability of the second teacher not having a car after the first has. That will be 20 over 49. And this is equals to, so let me just put it in my calculator, 30 over 50 multiplied by 20 over 49. That is 12 over 49. Okay, so I have 12 over 49. But this can happen in two ways, right? The first teacher selected may not have a car, and the second teacher might have a car. So let's look at the probability of that outcome. The probability that the first teacher does not have a car is 20 over 50, multiplied by the probability of the second teacher having a car, which is 30 over 49. Okay, I think we should end up with the same thing here, because on the numerator we have 30, 20. On the denominator, we have 40 and 49, which are also multiplying each other. So we're going to have 12 over 49 here. So the probability that that only one of the educators selected owns a car will be 12 over 49 plus 12 over 49. So let me put that in my calculator. I'm getting 0.49 if I run it off to two decimal places. So that is 10.2.2. Let's take a look at 10.2.3. Find the probability that the two educators selected each owns a car. So we want the probability that the two educators selected each own a car. So the probability of car. So this is what we're interested in, right? So the probability that the two teachers selected own a car will be 30 over 50. That's the first one. And then when we select the second one, we're left with 29 over 49. Okay, so 30 over 50 multiplied by 29 over 49. Let me just check if I had represented the data in the correct way. Yes, that is totally fine. Okay, when I put it in my calculator, 0.36. So 10.2.3, 0.36. Okay, I think we're done with that. 10.3, you require a password for an online account. The password must have 3 numerical values. So, well, let's make sense of that. 3 numerical values. So we need the numbers there. We need the numbers. Which numbers, we're not really sure about that, but we're going to figure it out. And then followed by 2 vowels. So we needed 2 vowels here. Vowels, obviously, A, E, I, O, U. How many possible passwords if repetitions are allowed? Okay, so numerical values, we have 0 to 9, which is 10, right? So we can have 10 here, one of the 10 numbers, one of the 10, one of the 10 vowels, one of the A, E, I, O, U, one of the 5, not 6. So 5 multiplied by 5. So this is just equals to 10 to the 3 multiplied by 5 to the 2. Whatever that is equals to, you're supposed to put that in your calculator and get some answer. Right. That is 10.3.1. Let's take a look at 10.3.2. Determine the number of possible passwords with the following conditions. So, okay, we still need those digits. We still need 5 digits. Yeah. Let's take a look. If repetitions are not allowed, the password does not start with a 0 and it ends with a vowel A. Okay, so this is the last position where we need to have A there. So how many A's do we have? We only have 1 A in our vowels. So it's only one possible vowel that can occupy that last spot. And then repetitions are not allowed. So here on the other spot that we need vowels, that we need to place a vowel, we are going to be left with 4 vowels because repetition is not allowed and A already occupies the last one. So we're going to have 4 possible vowels here. Okay, and then the password does not start with a 0. So if it does not start with a 0, it means that in this first position, we are not supposed to have 0. So of those 10 digits, we can only have 9 there on the first spot. Okay, so we have placed a digit on the first spot, which is non-zero. How many digits are we therefore left with? Well, we are left with 9. We are left with 9 digits here because we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10, right? We cannot place 0 on the first spot, so we are only interested on these 9 digits. All right, and then after we place one of those 9 digits on the first spot, let's say we place 7, we are still left with 9. So we have 9 multiplied by 9, and then ultimately multiply by 8 at the end, because any digit of the ones that are left can occupy that third spot. So there we go. You put that in your calculator and you get some answer. Those are the number of possible passwords with the given conditions. Here we go.